Welcome to E-Padasala PG program for computer science. Today we will be looking at serial port communication, as well as we will be comparing the serial port communication with parallel communication, and in this lecture we will discuss about RS-232 standard also. So, first before starting this particular serial port communication, first we need to know what is a serial communication and what is the kind of communications which are all available. Then we will be going ahead with the all other things. So, when I am looking at a communication, I will be sending from one place to maybe the sender to receiver. So, if I am sending it, if I am sending through only one line, that means bit by bit, then I will call that is a serial communication. And when I am looking at the data is sent parallelly, that means all the bits, a single word is sent at a time from sender to receiver, then I will say it is a parallel communication. When I am comparing these two things, the serial transfer will require only the resource as communication as only one wire. So, that is more than sufficient to transmit because we will be using only one bit. But when I am looking at parallel communication where I need more number of wires, maybe I will say that if it is 8 bit, I need 8 number of wires to communicate from sender to receiver. So, but the thing is here in the serial communication it takes more time, but when I am looking at parallel communication, there it takes only less time, but the resources needed is more. So, when I am looking at the serial communication, it has its own advantage and disadvantages. Parallel communication, if I wanted to send it fast, then people will go for parallel communication, but it needs more bandwidth also. So, when I am looking at serial communication, I will be sending a data bitwise, one bit after one bit. So, but when I am looking at the data will be given as a single word, that means 1 byte or 2 byte, that way a single word is given. So, when I wanted to send the data one bit after one, first I need to convert the word into bitwise data, then I will be sending that particular data through our transmission medium. So, when I am sending it, I will be sending it, if it is for a shorter distance, then I can send it through a single wire without doing any manipulation. That means the manipulation here is nothing but modulation. But if I am sending it for a longer distance, then I need definitely there will be a loss. So, to avoid that particular loss, I have to send it this one I have to send it for a longer distance with modulation. So, the data should be modulated, then it will be sent, and at the receiver side it has to be demodulated, then only you can take it. So, this is actually done through a modulator and demodulator. So, while we are doing a long distance communication, we need modulator and demodulator. So, when I am looking at this serial communication, we will be concentrating on serial communication in this lecture. So, in the serial communication we have two kinds of things. One is a synchronous transfer, another one is a asynchronous transfer. So, in the synchronous transfer we will be sending the data, that means a block of data will be sent at a time. But when you are looking at asynchronous data transfer, there a single byte only sent at a time. So, these things are supported with some hardware. With that hardware only it can be able to send. So, we have a UART, which is nothing but universal synchronous asynchronous receiver transmitter buffer, and UART buffer is also there. So, UART is nothing but universal asynchronous receiver transmitter. So, this UART supports asynchronous transfer. So, the 8051 microcontroller supports this, the 8051 microcontroller has inbuilt UART. So, asynchronous transfer is supported by the 8051 controller. So, when you are looking at serial communication, we will be having more kind of communication is there. So, the first thing is what way we will be communicating, what is the technology with which we will be communicating, that plays a major role. So, first thing is I will be looking at I have a two terminals, I am sending the data. If I am transmitting it, if I am be in a position to send in only one direction, then I will call that as simplex communication. So, when you are looking at terminal A to B or B to A, that means if I am sending it a communication from one direction only, then it is a simplex. But I may be having a possibility, I can have possibility of sending a data from one terminal to next terminal, maybe A terminal to B terminal. then maybe I will be in a position to send terminal B to A, that is also possible, but simultaneously I cannot send it both the things, though it has been connected with one wire only, but I can transmit in both the directions but not simultaneously, which is nothing but half duplex. When you are looking at, but sometimes we need to communicate from one, from A terminal to B terminal in one direction, the simultaneously I need to receive the data from B terminal to A terminal, then duplex can be used. Usually the duplex is called as full duplex. So these are the three ways people will be using the serial communication. So when you are looking at simplex communication, rather usually with the system, the simplex type of communication is supported by maybe a system is sending a data to a printer, then definitely from printer to the data will be sent from the computer to the printer, only that particular direction only communication is needed. So I can say that simplex communication is more than sufficient. When I am looking at, if the keyboard is connected to the system, maybe I will be sending the data from the keyboard, the characters, the signals will be sent to your machine, means then I will say that only one way communication is more than sufficient. So now if I am looking at system, there the simplex type of communication is efficiently used. Some of the devices where you need half duplex, some of the devices you need duplex. So based on the applications, people will go for this kind of communications. With respect to 8051, I will be I have shown that it has its built-in UART. So when you are looking at UART, it supports serial communication. Without that you can't do anything in serial communication mode. So in this actually we will be sending the asynchronous communication, which will be used for sending character oriented transmissions. So when you are sending a character, that means a single byte, this will be placed in between start and stop bit. So when you are sending asynchronous communication, a single byte at a time, if I am sending it, I will be attaching a start bit and a stop bit. So always a start bit will be only one bit will be used, and when I am looking at the stop bit, it may have a 1 bit, or some of the systems will have 2 bits also. But the start bit is always 0. With respect to 8051 with the UART, we have a start bit as 0, that means a low level signal, and stop bit is a high signal, which is 1. So when I am looking at the way of the data sending in this is LSB will be sent first, the MSB will be going last in that particular 8 number of bits. So the block oriented, if I wanted to send a block by block, that means a block of characters is sent, means then I have to rely on only synchronous method. So the when you are looking at serial, UART with the 8051, the start bit is always 1 bit and the stop bit is 1 bit. So that is the way only we will be having it. So with your 8051, this is the frame format with which the data will be sent in serial communication. You just see that here this is the stop bit. So this is a low level signal, and the 0. So this shows that this is the start of the signal, that means the word. And this is the bit 0, so bit 1, bit 2, bit 3 up to bit 7. So bit 0 to bit 7 combined together to make 1 byte data with respect to your 8051, 1 word. Now this is the stop bit. When I am receiving a start bit, I know that from there onwards I will be receiving the data. When I am receiving the stop bit, then I will say that this is the stop bit, because it is a high voltage, that means 1 is there. So the system will understand that from this after the start bit and before the stop bit, whatever be the data sent will be your data. So these are all combined together to make a single byte data. So when you are looking at the data transfer in serial communication, usually we will be saying that how many bits per second is sent. The speed of the data transfer is communicated with bits per BPS. We will say that bits per second, which is nothing but BPS, or people will usually call this as baud rate. So when you are looking at baud rate, we have a different baud rates with which the serial communication is supported. So we have 1200 bits per second, 2400 bits per second and 4800 bits per second and 9600 bits per second. So all these baud rates are supported, and lesser than that also this also will be supported, as well as greater than this baud rate also will be supported. But when you are looking at the system side, maybe if you are looking at the computer side, there is a standard technology which will be followed throughout is RS-232. So this RS-232 standard is followed for serial communication. If I am looking at serial communication, this standard tells you that there is an interface, this standard is maintained while you are interfacing the serial I/O devices. So here this standard is not supporting the TTL voltage level. That means this RS-232, what it does is, if I wanted to represent a 1 bit, then it will be represented by -3 to -225 volts. That means this negative voltage which will be represents bit 1, that means high bit. If I am looking at the bit 0, this will be represented by +3 to +25 volt. So when I am looking at these two things, I will be using 3 to 35 only. That means -3 to -25 and +3 to +25. Whereas this -3 to +3 is unidentified. Only these voltages are used for representing 1 bit and 0 bit. So if I wanted to connect an RS-232 interface to a microcontroller system, remember RS-232 is supported by all the PCs. So when you are looking at this RS-232, when I wanted to connect it to a microcontroller system, definitely I need to convert this kind of voltage system to TTL level, because your microcontroller supports TTL logic levels only. That means this TTL level logic will be supporting only a lesser voltage levels. So now when I wanted to connect or interface PC serial interface, PC as a serial interface with microcontroller, then definitely I need to make this RS-232 should be compatible with this whatever be the microcontrollers. So by the time, that means I need this RS-232 is converted into TTL level. So that kind of conversion definitely needed, then only it can be interfaced. So for that particular purpose, people are going ahead with some IC chips which is commonly referred as line drivers. So this MAX 232 or 233 are the IC chips commonly used for converting whatever be the RS-232 support to TTL level support. So this actually IBM has given this DB9 version of serial I/O standard, where you just see that we have 9 number of pins are there. First pin is data carrier detect, and the second pin is receive the data, and your third pin is transmit data, and your fourth pin is your data terminal ready pin, and fifth is your signal ground pin, your sixth is your data set ready pin, whereas your seventh is request to send, eighth is clear to send, and 9 is the ring indicator. So when you are looking at all these 9 pins are available, but when we wanted to connect it with 8051 or any microcontrollers, we will be looking at minimum minimum 3 pins is more than sufficient. That is, we wanted to have a receive data, send data, as well as the ground signal. So you wanted to have the ground pin, we need to have the transmit data, we need to have a receive data. So all these 3 pins are very important when you are looking at an interface of your RS-232, that means DB9 version of IBM pin connector to your microcontrollers. So when you are looking at this, they have made it, actually this RS-232, what they have done over here is, they said there are 2 kinds of system equipments which are there, which will be, one is DTE, that is data terminal equipment, where we will say that it is just like your computer. So computers are the terminals which will receive and send serial data, which is nothing but DTE. Whereas the data DCE is another one, where the data communication equipment, whereas this I can say that this is meant for communication purpose. example is your modem. So if I am connecting it modem, then I mean with the serial kind of communication, then I will refer that kind of systems as DCEs. So DTEs, DCEs are very important when you wanted to communicate with your I mean when you are making certain applications with respect to interfacing any of the computers or some communication oriented equipments. So the simplest connection between a PC and microcontroller requires only minimum of 3 pins, which is RxD, TxD and ground pin. As I said earlier, these 3 pins are very important, and all other pins maybe will not be using it for the other purposes. So you just see that if I have a DTE as well as maybe a microcontroller, I can connect the transmission of one DTE to the receiver of the second DTE. Maybe if it is a microcontroller, I can call this as microcontroller. When I am looking at the transmission of the second DTE to the receiver, this is the way it gets connected. This is transmitting, it has been connected to receiving side, and this is transmitting and it has been connected to a receiver. So remember, there is a single bit connection. So because of that, only one pin is more than sufficient to connect for TD to RxD and TD to RxD, and ground for both the machines should be connected properly. Then only the communication can be done properly. When you are looking at your 8051 to RS32, as I said, 8051 will not support RS232 kind of interface. So what they have done over here is they will be using something like MAX 232 chip. So MAX 232 or MAX 233 chip, which will be in a position to interface 8051 with your RS232 computer based serial communication devices. So when you are looking at over here in 8051, there are 2 pins which will be used for transferring and receiving data serially. So in this, the TXD is a transmission pin. The data will be transmitted through this particular TXD pin, and the serial data is received through this RxD, and it is available in the port 3, that is port 3, 0th pin and first pin, 3.0 pin and 3.1 pin. So that in the IC chip, it is pin number 11 and pin number 10. These two are used for connecting serial communications, and these pins are definitely a TTL compatible. That means it will support only a lower voltages. And the line driver, we need a line driver. That means we wanted to make RS232 to be compatible, so we need a line driver so that this is compatible. So the line driver here is specified as MAX 232 or MAX 233 chips. So when you are looking at MAX 232, this converts 232 voltage levels to TTL voltage, and which is acceptable by 8051. Where when you are looking at your MAX 232, which otherwise called it as a line driver, which uses plus 5 volt power supply, same as the source voltage which is required for 8051. So no need to go for a separate power supply for this particular converter, and no dual power supplies is needed to connect your 8051 as well as your MAX 232 chips. And MAX 232 has 2 sets of line drivers. You can at a time you can use 2 line drivers converting from TTL to this RS232 standards. So when you are looking at TXT, line drivers used to TXT are called T1 and T2, whereas line drivers for RxD are designated as R1 and R2. Though it has 2 sets, we will be using only 1 set, and the second set is not used. In this 232, MAX 232, we have capacitors also connected over there in the pins 1, 3 and 4, 5, where you just see that 11 and 12 is T in and T out. That means if I am putting the transmitted bit over here, this is converted into RS232 format and it will be available in 14th pin. If I am giving a receiving bit as TTL, RS232 compatibility or RS232 kind of signal at this particular pin, I can get out the TTL set of output, TTL compatible serial output at this particular pin. See, this is the connection, this is the way the connection is done. That means MAX 232 11th pin is connected to 11th pin and the 12th pin is connected to 10th pin of this RxD. So here you just see that this MAX 232, we have extra capacitors are there. So to avoid that, people are going towards MAX 233, where it is used to save the board space. It performs the same space as well as it eliminates the capacitors, but anyway it is expensive than 232. When you are looking at max 233, the capacitors are avoided, but all other configuration is similar. So you just see this is TTL side and this is RS232 side, where RS232 whatever be the thing will be getting it, will not using the second set, will be using first set. It has been connected like this way. So T in is given over there and it will be given as T out, R in is given over there, R1 out is given over there. So the compatibility between TTL and RS232 has been achieved through max 23. So this solves the problem of connecting microcontrollers with your terminals, that means computers, to process certain things. So though we have interfaced all these things, with 8051 itself we need so many things, so that we will make all the data to be serialized. So we have a, when we are processing a data, when you are reading a data, or when you are whatever be the data we are handling it in 8051, that will be in a 8-bit word only. So when you wanted to send it as bitwise, then we need to have, it has to be placed in one place so that it gets serialized and it will be sent. So the same way, when I am receiving a bit after bit, I need a place where I have to store all these 8 bits. After that I will concatenate all the things. I have to make a single word, then I can give it to 8051. If I wanted to do that way, then I need, somebody has to take care about this particular process. The temporarily it has to be stored and it has to be transferred. So the interfacing buffer is nothing but here is serial buffer. So SBUF is the register which is used for which is used as a interface between whatever be the data we are giving it processed inside your 8051 to serial mode communication, as well as whatever be the thing we are receiving it serial data which has been combined at SBUF and it has been given as a word to your 8051. So the 8051 the second problem here over here is, when I am receiving a data which will have a stop bit and stop, also the UART standard, when we are looking at, we have a stop bit and start bit which will say that this is the data bit coming in between. So these two things has to be removed before giving this word towards the system, whereas while we are sending it, it has to be attached. So these process also has to be done at SBUF only. And all your data set, when I wanted to send it serially here and there, the system has to know what kind of transmission is done and what is the setup we wanted to have, what is the speed with which I have to do, whether we have transmitted fully or not, whether we have received fully or not, is there any time has to be maintained to make the bit has to be sent in the correct baud rate. So all those things has been controlled by serial communication control register, which is otherwise called SCON register. So anyway, in the next lecture we will be looking at all these things in detail, but anyway, this SCON register is also a 8-bit register where this TI, RI as well as REN and SM1, SM0 are very important to configure what is happening inside your serial communication. That means the control register is telling the information to the system or to the to the outsider what's happening inside it. So it is just like a status register which tells about which communicates about the serial communications parameters. And actually the next very important parameter with 8051 is what is the speed with which we will be sending the data. That means when I wanted to communicate to a PC, the PC accepts in which speed that we wanted to know. So based on that only I can send the data from microcontroller, or I will be interfacing some other system for doing certain application, then I need to know what is the speed with which it will be receiving the data. The same way, when I am interfacing some other device which is giving the input to 8051 for making a particular application, and that particular device is of a serial communication device, then I need to know what is the speed with which it is giving the data to my 8051 controller. So if I am knowing these two things, then I will be in a position to configure that particular speed. So for doing, after configuring that particular speed, then only I will be in a position to transfer the data smoothly from 8051 to the outside device or the input devices to 8051. So we must, I mean, this has been handled with the help of timers as well as the oscillators inside your 8051. Anyway, when you are looking at the communication of 8051 with the outside world or from outside world to inside world through serial communication, then definitely we can't handle it directly. It has to be, the data should be either converted from parallel form to serial form or from serial form to parallel form. This has been done by somebody, some interfaces. So with that interfaces only we will be in a position to process the data or read the data properly in 8051. Anyway, how you will be, how this has been achieved, this will be dealt in next lecture in detail. So in this lecture we have discussed the basics of serial communication with respect to 8051, as well as we have discussed the different communication methodologies, maybe the serial communication as well as parallel communication, its advantages and disadvantages, and at the end we have discussed the serial communication concept with respect to 8051 and the regular RS-232 IO interface standard in the computer industry. So with this we have concluded the serial communication basic concepts. Thank you.